Hi, this is Rémi Lafage from Onera, and today in this video I would like to show you how we have integrated the egmdo method in WhatsOpt. egmdo stands for Efficient Global Multidisciplinary Design Optimization and is developed by Sylvain Dubreuil here at Onera. So in WhatsOpt we have integrated part of the method. Basically, the idea here is to replace some of the disciplines of the analysis by surrogate models, by creating surrogate models, then converge the MDA, enriching those surrogate models while controlling the accuracy of the outputs of the analysis. Here we have F, G1, and G2, which are the variables and the objective and the constraints of the optimization problem. So how do we activate egmdo here in WhatsOpt? We start by editing the analysis. In the OpenMDAO tab, we select the discipline 1 and discipline 2 as being replaced by a surrogate model. And then I can save this configuration. You can see here that I use Kobila, which is a gradient-free optimizer, just to let you know. And now we can go back to the shell command. Here I've already pulled the code, but here I update the code with the egmdo option. So to generate the code for the method. So we can see here we have a new egmdo directory with the relevant code for the method. And now I can run a new script, which is run egmda. The egmda is actually the MDA, but using surrogate models. And I'm going to use the plot option to display some graphics to show you what is going on behind the scene. So I run that script, and I get an error. Yes, to use the egmdo, we have to specify the bounds for the state variables. So here, y1 and y2. I need to specify here that y1 is between 0 and 50, and the same thing here for y2. We get those values from previous experiment, and I would say the method is robust, even if you have approximations of those bounds, the method is still able to converge. So maybe with more time, but still able to converge. So now I go back to the shell command and I update the code as always to take into account the changes. And now I run the egmda. So the method starts by generating a DOE of 4 points to create the first surrogate model for discipline 1. So here you can see just a plot of y1 with regards to the inputs of the discipline 1. And we generate the initial surrogate model. And then for the discipline 2, we get the same. So y2 with regards to the inputs of discipline 2. And we generate the model. And then the method starts iterating. So the first iteration, we compute 500 times random MDA using the surrogate models. So we can display here the mean of the y1 variable with its uncertainty, the 3 sigma uncertainty here in blue, and the same for y2 in red. The mean and its uncertainty. And we can see, and the method compute, that we need to reduce the uncertainty on the y2 variables. So we have to enrich the surrogate models of the discipline 2. So we are doing that. And then again, we are running 500 times the random MDA, and we can see that we have reduced here the uncertainty on the y2 variable, but now we need to reduce the uncertainty on the y1 variable. So we need to enrich the surrogate model of the discipline 1. So by calling once the true discipline 1 on a new waypoint, new point, and then we are creating again the surrogate model, and the method keep on iterating, and then we can see here we converge pretty quickly. We get the values, the output values of the f, g1 and g2. We can compare those values to the true MDA. So here I can, maybe I'm going to delete some cache files, and here run the true MDA, and we can see we get, well, approximately the same values with the default parameterization of the method. We can see here we call 8 times discipline 1, while using the EGMDA we call the discipline 1 5 times. But now the very interesting part is that we can run the optimization using the EG MDA. So we are doing that using the other script run egmdo, and then we can see that the method well iteratively enrich either the surrogate of the discipline 1 or the discipline 2 to optimize the problem and run the EG MDA. I've put some output on the computation of discipline 1 just to see how many times we call discipline 1. We can see 38 times, 39, 40, 41, 42. Okay, so here we get the right results, the optimum of the Cellar problem. We can go back and just check how many times we have called the discipline 1. So 44 times. And now we can compare with the classic MDO script. So the optimization using the classic MDA. Maybe I need to reset some cache file before starting the script. Yeah, like that. And so we can see that, well, the script ran faster, but we can also see that we have called 287 times the discipline 1, so something like 7 times what we have done with the EGMDO. So well, and we get, well, you can see we have got also the same results. So to conclude, we can see that the EGMDO method allow to make multidisciplinary optimization while calling the disciplines as little as possible. And Actually, if you have a time-consuming, expensive discipline, well, the more expensive the discipline are, the more AGMDO is useful and shines. So this is the conclusion of this video. Thank you for watching and see you next time. Bye bye.